Preparing for a DevOps at Wells Fargo interview? You've reached Candy Mentor, and this video is for you. We'll walk through 20 key questions you're likely to face. For each question you'll see a sample answer followed by the key points to cover. Subscribe, like, and share, and drop a topic request in the comments. Question 1. How would you design a secure CI/CD pipeline for a banking application at Wells Fargo? I would build an immutable pipeline that promotes the same artifact through development, testing, staging, and production. Every commit would trigger unit, integration, SAST, dependency, container, and infrastructure scans. Secrets would come from a managed vault, never source control. Production deployment would require policy-based approval, separation of duties, complete audit logging, and automated rollback. For a bank, evidence retention and change traceability are as important as deployment speed, so compliance controls must be embedded rather than handled manually afterward. While answering, cover source control, automated testing, artifact promotion, secrets management, security scanning, approvals, audit trails, segregation of duties, rollback strategy, and controls supporting regulatory compliance without creating unnecessary delivery delays. Question 2. What is the difference between continuous integration, continuous delivery, and continuous deployment? Continuous integration means developers frequently merge changes and receive automated build and test feedback. Continuous delivery keeps every validated change ready for production, usually with a controlled approval step. Continuous deployment goes further by releasing automatically when quality gates pass. I would likely use continuous delivery for sensitive banking services, combining strong automation with risk-based production approval. The right choice depends on service criticality, test confidence, operational maturity, and regulatory expectations, not on pursuing automation for its own sake. Make sure to define each practice, explain automation boundaries, distinguish deployable code from automatically released code, and discuss how risk-based approvals and testing would influence adoption in a regulated banking environment. Question 3. How would you implement infrastructure as code for a multi-environment platform? I would use Terraform with versioned, reusable modules and separate environment configurations. State would reside in an encrypted, locked remote backend with restricted access and recovery procedures. Changes would flow through pull requests, plan reviews, policy checks, security scanning, and controlled applies rather than local commands. I would pin provider versions, detect drift regularly, and keep secrets outside state whenever possible. This creates repeatability and auditability, while module boundaries prevent every team from inventing infrastructure differently. In your answer, talk about Terraform or equivalent tooling, reusable modules, remote state, environment separation, review workflows, policy checks, drift detection, secrets handling, version pinning, and safe state recovery. Question 4. How would you manage secrets and credentials across DevOps pipelines and production systems? I would centralize secrets in a managed vault and grant workloads short-lived credentials through identity federation or workload identity. Pipelines should retrieve secrets only when needed, mask them in logs, and avoid embedding them in images, repositories, or Terraform state. Access would follow least privilege, with rotation, expiration, audit trails, and emergency revocation. Applications should fail safely when credentials are unavailable. For regulated systems, I would also review access regularly and document ownership for every secret. Be sure to mention vault-based storage, short-lived credentials, rotation, least privilege, workload identity, masking, access auditing, emergency revocation, and preventing secrets from appearing in logs, images, repositories, or state files. Question 5. Describe how you would deploy a high-availability service with zero or minimal downtime. I would run multiple healthy instances across failure zones behind a load balancer, with readiness checks and connection draining. For releases, I would prefer canary or blue-green deployment, shifting traffic gradually while monitoring errors, latency, and saturation. Database changes must be backward compatible, expand first, migrate, then contract later. Automated rollback should stop promotion when thresholds are exceeded. High availability is not just redundant servers, it also requires tested recovery procedures and realistic operational monitoring. Focus on load balancing, redundant instances and zones, health checks, backward compatible database changes, rolling or blue-green releases, connection draining, observability, rollback, and validating availability against defined service objectives. Question 6. How would you troubleshoot a production deployment that suddenly increases latency and error rates? I would first declare or join the incident, establish impact, and compare metrics with the deployment timeline. I would inspect request traces, error patterns, resource saturation, dependency health, and recent configuration changes. If the release is the strongest hypothesis, I would halt promotion and roll back or shift traffic to the healthy version. Throughout, I would communicate status and preserve evidence. After recovery, I would lead a blameless review and add tests, alerts, or safeguards addressing the actual failure. Cover incident declaration, recent change correlation, dashboards, logs, traces, saturation signals, rollback criteria, blast radius reduction, communication, evidence preservation, and post-incident analysis focused on prevention rather than blame. Question 7. What observability strategy would you use for a distributed banking application? I would combine metrics, structured logs, and distributed traces, using a correlation ID across API calls and asynchronous messages. Dashboards would show latency, traffic, errors, and saturation, plus banking-specific indicators such as transaction failures and reconciliation delays. Alerts should be tied to service-level objectives and actionable symptoms, not every unusual event. Telemetry must exclude sensitive customer data, enforce retention policies, and support access auditing. Good observability helps engineers detect customer impact before infrastructure metrics look alarming. In your answer, cover metrics, logs, traces, correlation IDs, golden signals, business indicators, dashboard design, alert thresholds, data protection, retention, and linking telemetry to service-level objectives and incident response. Question 8. How would you apply DevSecOps practices throughout the software delivery lifecycle? I would shift security left without treating it as a single scanner. Design reviews would include threat modeling, while commits trigger secret detection, SAST, dependency analysis, and unit tests. Built images would receive vulnerability and configuration scans, and deployed environments would undergo policy validation and runtime monitoring. Gates should distinguish critical exploitable findings from acceptable risk, with documented exceptions and owners. Security teams and developers should share feedback loops so remediation becomes part of normal engineering work. Make sure to discuss threat modeling, secure coding, SAST, DAST, software composition analysis, image scanning, infrastructure policies, secret detection, risk-based gates, remediation ownership, and continuous security monitoring. Question 9. How would you choose between Kubernetes, virtual machines, and serverless for a banking workload? I would choose based on workload and control requirements rather than platform fashion. Kubernetes suits containerized services needing portability, consistent orchestration, and fine-grained deployment control, but adds operational complexity. Virtual machines can provide simpler isolation and compatibility for legacy workloads. Serverless reduces infrastructure management and scales well for event-driven tasks, though runtime, networking, and observability constraints matter. For a banking service, I would validate each option against data protection, resilience, auditability, latency, cost, and the team's operating maturity. Discuss workload characteristics, operational complexity, portability, compliance, startup behavior, scaling, networking, observability, team maturity, cost, and whether the platform choice satisfies security and reliability requirements. Question 10. Explain how you would implement a safe database migration in a continuously delivered application. I would use an expand and contract approach. First, add nullable columns or new tables without breaking the current application. Next, deploy code that can read and write both representations, backfill data in throttled batches, and verify consistency. After traffic uses the new path, I would remove the old structure in a later release. I would test migration duration, locking, replication impact, and recovery beforehand. Database rollback is often difficult, so compatibility and backups matter more than simply reversing code. Be sure to mention backward compatibility, expand and contract migrations, transaction safety, backups, replication, performance testing, feature flags, rollback limitations, monitoring, and coordination between application and database releases. Question 11. How would you design disaster recovery for a critical financial service? I would begin with business impact analysis to establish recovery time and recovery point objectives, then map application, data, identity, network, and vendor dependencies. Depending on requirements, I would use resilient multi-zone deployment, replicated databases, encrypted backups, and a tested secondary region or site. Failover procedures would be automated where safe, documented in runbooks, and exercised regularly. Success means validating data integrity and customer workflows, not merely proving that servers can start elsewhere. Focus on business impact analysis, RTO, RPO, multi-region or site resilience, backups, replication, dependency mapping, failover automation, data integrity, regular exercises, runbooks, and evidence that recovery objectives are actually achievable. Question 12. How would you implement canary releases and decide whether to promote or roll back? I would release to a small, representative percentage of traffic or internal users, isolate the cohort, and compare it with the stable version. Promotion criteria would include error rate, latency, resource use, dependency failures, and relevant business outcomes. Automated analysis would pause expansion when thresholds or statistically meaningful regressions appear. Feature flags provide an additional control for behavior changes. The canary must receive realistic traffic. Otherwise, a green result can create false confidence. Cover traffic segmentation, representative cohorts, automated health metrics, statistical comparison, feature flags, progressive rollout, customer impact, rollback triggers, observability quality, and avoiding biased conclusions from insufficient canary traffic. Question 13. What would you include in a production readiness review for a new service? I would verify that the service has a clear owner, documented architecture, data classification, threat assessment, capacity model, and dependency inventory. Operationally, I would require dashboards, actionable alerts, health checks, runbooks, on-call coverage, backup and recovery evidence, tested deployment and rollback procedures, and defined service objectives. I would also review load, failure, and security testing. A readiness review should expose unresolved operational risk before customers discover it, not become a checklist completed after launch. In your answer, cover architecture, security, capacity, resilience, monitoring, deployment and rollback, dependencies, runbooks, ownership, support coverage, data classification, compliance evidence, and load or failure testing. Question 14. How would you reduce build and deployment times without weakening quality or controls? I would measure each pipeline stage first, because optimization without data can move the bottleneck. Then I would parallelize independent tests, cache dependencies, use incremental builds, reuse immutable artifacts, and separate fast pull request checks from deeper scheduled validation. Flaky tests need ownership rather than being silently ignored. Ephemeral environments can improve integration feedback when cost is controlled. I would preserve security scans, approvals, traceability, and evidence. A faster pipeline that increases production risk is not an improvement. Discuss pipeline measurement, parallel execution, dependency caching, incremental builds, test categorization, artifact reuse, ephemeral environments, quality gates, flaky test management, and preserving security, auditability, and reliable release evidence. Question 15. How would you use configuration management and feature flags safely in production? I would externalize non-secret configuration, validate it before deployment, version changes, and restrict production modification through audited workflows. Secrets belong in a vault, not ordinary configuration. Feature flags would support gradual rollout and rapid disablement, but each flag needs an owner, expiry date, tested combinations, and clear default behavior. I would monitor flag changes like code changes and avoid accumulating permanent branches. Configuration flexibility is valuable only when it remains understandable, reviewable, and recoverable. Make sure to cover externalized configuration, validation, versioning, access control, sensitive values, staged rollout, flag ownership, expiration, audit trails, kill switches, and preventing configuration drift or untested combinations. Question 16. How would you manage compliance and auditability in an automated DevOps process? I would make every production change traceable to an approved work item, commit, build, artifact, test result, approver, and deployment identity. Pipeline permissions would enforce least privilege and separation of duties, while policy as code would validate infrastructure and release requirements consistently. Logs and evidence would be immutable, time synchronized, retained according to policy, and accessible only to authorized reviewers. Automation should produce audit evidence automatically, reducing manual errors while preserving accountability for the people and systems making changes. Focus on immutable records, change tickets or linked commits, approvals, identity, least privilege, segregation of duties, policy as code, evidence retention, access reviews, and making controls repeatable instead of manual. Question 17. How would you handle a vulnerability discovered in a production dependency? I would identify affected applications from the software inventory, assess exploitability and customer exposure, and prioritize according to severity and business risk. If exploitation is plausible, I would apply temporary controls such as blocking paths or tightening network access while testing an upgrade. For urgent cases, I would use the emergency change process with documented approval and monitoring. After deployment, I would verify the version in running artifacts and review why detection, ownership, or patching was delayed. Be sure to mention severity and exploitability assessment, asset inventory, exposure analysis, compensating controls, patch testing, emergency change procedures, communication, verification, and improving dependency governance afterward. Question 18. How would you monitor and control cloud costs in a DevOps organization? I would establish mandatory ownership and environment tags, allocate spend to teams and services, and create budgets with anomaly alerts. Dashboards should connect cost to useful units such as transactions or customers, not just monthly totals. Engineers can then right-size resources, tune autoscaling, remove idle environments, use lifecycle policies, and select appropriate purchase models. I would enforce guardrails through infrastructure policy, but never reduce redundancy or security blindly. Cost optimization should improve efficiency while preserving reliability and compliance. Discuss tagging, ownership, budgets, anomaly detection, right-sizing, autoscaling, reserved capacity, environment scheduling, unit economics, governance guardrails, and ensuring cost optimization does not compromise resilience, security, or performance. Question 19. How would you improve collaboration between development, operations, security, and compliance teams? I would create shared service objectives and involve operations, security, and compliance early in design and planning. A platform team can provide paved roads for repositories, pipelines, observability, identity, and compliant infrastructure, reducing repeated effort. Teams should own services through production, supported by clear runbooks and on-call expectations. Regular incident reviews and architecture forums build trust when they focus on learning. The goal is not to make developers perform every specialty task, but to make safe behavior the easiest path. In your answer, cover shared ownership, platform enablement, common objectives, paved roads, documentation, incident learning, embedded controls, developer experience, communication, and resolving conflicts through measurable risk and delivery outcomes. Question 20. Tell me about a DevOps improvement you would propose during your first 90 days at Wells Fargo. During my first 90 days, I would listen and measure before proposing a broad transformation. I would map the delivery path, interview developers, operations, security, and compliance partners, and baseline lead time, deployment frequency, change failure rate, recovery time, and pipeline reliability. I might pilot standardized secure pipelines for one service, targeting faster feedback and stronger evidence. I would publish results, capture team feedback, address risks, and scale only after proving the improvement is sustainable and compliant. Focus on discovery before change, measurable baseline metrics, stakeholder interviews, risk assessment, a limited pilot, quick wins, success criteria, feedback, documentation, and scaling only after demonstrating security and reliability benefits. If you are still with us, congratulations, you are much ahead of the rest and serious about preparing for your interview. We hope we were able to add value to your preparation and create some helpful content. Do not forget to like and share this video. Your small act can do great things for us.